করে দিছো অন করতে না করছি পজ দাও So, assalamu alaikum. In our last class, we have got to know about the 7-second display, right? Sabir? In our last class, we have got to know about our 7-second display. Is it? Okay. 7-second display. What's the topic of our last class? 7-second display, the basic of 7-second display, the LED, how they works actually. Now, what is the significant outcome of the display? Display is just a piece of what? It's a collection of matrix. Sorry, in a sense, yeah, that is diode, 7-second display is diode. LCD display is a summation of matrix, okay? I mean row and column in the sense of the element of the matrix will represent as a value of the outcome of any kind of systems. So, in 7-second display there are lots of LEDs. I am just reviewing the last class like A, B, C, D, E, F, G, H, and there will be a dot as well. So, basically there are 8 LED in a sense that consider to the output of any kind of system or any kind of setup or any kind of project. So now we will develop a system, okay, or project, and the outcome will be the result of the display, the output of the display, okay. So you want to show the system, the value of the system. Like right now I am conducting a cricket match, Imrul guys hit a 6, that's the over boundary. So how we will get to know and how we will represent the 6 to the audience? There should be a value of 6. So the value of 6 is something like this, okay. So in a display, the value of 6 something like this, 1, 2, 3, 4, 5, is it? So there will be 5 LED like A, B, C, D, E, okay, F, okay. There will be 6 LEDs over there, yes, and there will be 1 and there will be another. So that's why it is segmented in a 7 pieces of 7 separations. That's why it's called 7-second display. Now it's the output of the match, cricket match, or the 6 of a batsman that he hit over boundary, okay. Now my question is, we can show any kind of value that will be resulted of a system, is it? If it's something like that, we have a sensor like LM35, which is a temperature sensor, okay, so which is a temperature sensor. So the temperature sensor is something like that. It will take the data from the environment, it will collect the data from the environment. Like right now I am sweating a lot and probably you will feel cold that you are sitting just in the linear line of the AC. That's why the temperature will vary according to the what? Condition of the air, condition of the system, about the humidity and overall positions actually. Now this sensor will collect the data and there will be some processing unit, as I say, what? There are 3 blocks, 1, 2, 3. So it will take the input, there will be a processing unit, CPU or microprocessor, microcontroller, and there will be another unit that will be considered as an output. So this is the output is 7-segment display. This input is LM35 because it will take the data from the environment, okay, And what will be the CPU? There will be Arduino Uno to conduct the values, to process the values and show the outcome to the 7-second display. So that's the main summary, that's the main scenario. Okay. If you look at the page number 10, figure number 1.9, multiplexed display unit for 3-digit thermometer. Yeah. Do you get it? So just think about that. If you look at the picture, you will be puzzled, you will be astonished, and you will be afraid. And how can I conduct these sessions? How can I draw this diagram? But it's very easy to draw. Okay. So there will be a middle part. Say there is Uno. You can watch over there. There is Uno. So just forget about the pins and the blocks. It will make it complicated and puzzled you. Okay. So just think about there is Arduino Uno, a processing unit, which will process the overall circumstances. Okay. Now, what it has doing right now, there is a T degree Celsius over there. What is the meaning of T degree Celsius? Is a temperature. It could be 35 degrees Celsius, 33 degrees Celsius, 31 degrees Celsius. Okay. And there is a 3 pin over there. How many pins over there? 3 pins. Okay. One pin is ground, 1, 2, 3, 1, 2, 3. One is V in, this one is ground, and this one is V output. So 3 pins consider to 3 significant values. V input, it will take the input. Ground means to complete the circuit, you need a ground. Basically, to power up or to carry on its result, you need 2 things. One is plus and one is minus. So V output is a plus, and this minus is the ground. You get it? And as it takes the value from the environment, there will be a V in pin. Okay, these are the sensor pins actually. Fine. So it takes the value from the environment. So there will be a result over there. I mean, there is no result. There is the temperature. So now the Arduino can feel the temperature. Is it so? It's not something like that. So is the mechanism of transducer that we have got to know about in the last semester or the previous semester or before that? Exactly. Physical signal or the value of the environment or the any kind of signal will convert to electric signal. Like there will be pressure. Okay. If I press to the field, then that pressure will convert into electricity. Like how much volt that can be produced. Okay. It could be 1 volt, 2 volt, 3 volt. Fine. So there will be a transducer over there. You can put over the force over there. You can put force over there, and this force will convert to a electrical value, I mean voltage. Electrical value means voltage. So if there is a voltage, there will be current. Fine. Now I have to connect this one to the Arduino Uno. Okay. So as you know, did you attend the midterm? What is his name? Did he attend the midterm exam? Did you attend the midterm exam? Okay. That's really thing to worry about. Okay, fine. So in our previous syllabus, we have learned the port pin, the Arduino pins. So Sabir will get it very easily because there will be some port A, port B, port C, port D. Okay. So this refers to a digital pin, analog pin, and other pins as well. Now, in the Arduino Uno, there is a pin, something like that. See, 10-bit ADC, channel 5, channel 4. So this value is an analog value. Okay, so you can put it to the digital pin in another sense, analog and digital. So if you put it to the analog value, then you can work on the bigger range, and if you put it to the digital value, you can get the same result. Okay, there will be no difference. But LM35, just let me check. Do you know LM35 is a digital sensor or analog sensor? Do you know the difference between a digital sensor and analog sensor? So analog sensor is something like that. the temperature will take the value and process it to analog results, analog component. And if you want to work on the digital sensor, then it will work on the digital sensor as well. To work with the digital sensor is very much easy, because you have to play with just 0 and 1. And to work with the analog sensors, it's get the same result, but the code will be little bit different. That's the main significant difference you can find. So as far as I know, LM35 digital or analog. Let me check. I just forgot about that. Analog sensor. Okay. So LM35 is a temperature measuring device which is an analog output. So if you get this V out, is it analog or digital? Analog. Okay. So your output over there is analog. Do you want to connect this analog to the digital sector or the analog sector of the Arduino? Analog. Because analog has the compatibility with the analog sections. So there is an analog portion is called what? ADC, analog to digital converter, ADC, and it will performs with the 10-bit values. Okay, perform the 10-bit values. Fine. Now our main motto is, see, to the analog side, what it consists. It has A5, like A5, A4. If you consider it to Arduino, okay, so these are the analog sections and these are the digital sections. Fine. And there is a port over there to connect. There is a reset pin, there is an oscillator, there is a MCU. Okay. So A5, A4, there is a 5-volt ground. Is it? Nice. Now our main motto is to get the value from the V in, okay, and then what I have to do, see, the one is there is a little mistake over there. Yes, signal bill is connected to the A4. Okay, fine. See, to this V output pin, what will connect? Just look at the image. What you will connect? Can you please explain what will you connect with the signal pin? Okay, just get to know about the LM35, how this LM35 works. How can I connect this ground pin to the Arduino? How can I connect this V in and V output to the Arduino? Do you have any kind of idea about that? You should know about that, please. Okay. Now, just look at the picture and do you have any idea that VCC, I mean this V output pin, considered how much voltage over there? You have any idea? 4 to 10 volt or more than that. Okay. So, and this is the operating voltage. Okay. This is the operating voltage. So here I can see there's a little mistake over there. This, the center pin is a VCC, same shape. It's the same thing actually. This is the ground and this is the V output. It doesn't matter if you can swap it over there. It doesn't matter. The ground is the pin. This is the ground pin. Whatever it is, you get numbering in your consequences, in your way, like 1, 3, 2. Okay. So then you can shift the pins and connect it to the Arduino. Now my question is, would you please connect this V in and a V out to the Arduino analog? How can you connect these pins? How? What? Exactly. So it will produce the analog value. Now we will connect it to the A4. Simple. So V in pin is what? So it will get power. Okay. So how may I get this power to this 5-volt pin? Let me make it very clear. 5-volt ground. So this is the 5-volt connection. This is the ground connection. And okay. So this is the same picture that had been portrayed in your slide. Now the question is, we have connected these pins over there, how it works internally. Basically there is a bit pin over there that works from 0 to 9, if I am not wrong. B9 to B0 actually, B9 to B0. So if you start from B0, B0, B1, B2, B3, B4, B5, B6, B7, B8, B9. So it is a 10 bit. Okay. So I have considered a box over there 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it will like B0, B1, B2, B3, B4. Okay. So these are the values actually. What these values represent? These values represent the analog consequences, the analog results. If you find something in 10 bit, I hope you have learned the basic items and the basic algorithms of ICT. Okay, analog to digital, binary to octal, okay, binary to decimal. So if you put the binary number over there and convert it to what? To the integer, I mean decimal number, then you will get the value like 35. Okay, but in Arduino it does not work something like that. It works with the bit process. It will process the bit and give you the output, and there is a formula over there. I will get to know about that. Okay, so there is a formula over there, and obviously here is a V reference pin. Okay. So in this V reference pin, I think there is a 1.1 volt or something like that. Yes. So you have to connect the 1.1 volt. Okay. So that is the old procedure, but as we are conducting the syllabus, the title microprocessor interfacing, so I am providing you the lecture like this. Okay. So you have to connect the 1.1 volt with the V reference. Okay. Did you start the video? Okay. 1.1 volt. Now, my question is, if there is a 1.1 volt, now how can I get the result? So, in the input section, I have set up all these sensors and the other stuffs. I have configured the exact setup with the for the interaction of LM35 to the Arduino Uno. Now, there is a different sections over there, and that's the output sections. So this output section is something like the 7-second display. Now tell me just tell me one question, just tell me one answer.
How
yes.
we connect the Arduino with 10-bit ADC?
There is an internal 10-bit ADC with the Arduino. It is internally set up. That's why I am telling you the value will be something like this, and it will comes as an output of decimal value.
Only we can connect the output in.
You have to connect something like this, and the Arduino will process automatically. But you have to put the command over there. It won't work if you put the command over there. And the command is equal to coding, programming language, and that is the basic interface of Arduino, which is C++. And to understand very easily, Arduino has its own language, that is IDE. Sorry, that is Arduino. This is the language. Okay, this is not the piece of component. It's a language. Arduino itself is a language. The interface of C++. Okay, so this Arduino. So you have to command with that Arduino language, but I'm not going through that process right now. I'm just setting the circuit. Okay. So what's the output? 7-second display. Now my question is to you. Ask him. Just knock him. My question is, if we measure any value, the temperature, how could we portray it? Like, how will you see the result in a display? 3 degree, 35 degree, or 100 degrees Celsius? If you look any kind of screen, what you can see? 3 degree, 30 degree, 90 degree, 120 degree. What you can see the maximum? 30 degree. Can it be more than 30 degree? 100 degree? Is it possible? Okay. So 100 degree. So if I consider the 100 degree, it's possible because the boiling point of a water is 100 degree, isn't it? So if you want to see the 100 degree, so to get the value of 1, may I get this value of 1 to the 3 display or 1 display or 2 display? Only 1 display. To get this value 1, we need 1 display. To get this value 0, we need another display, and to get this value 0, we need another display in consequent. So we can set a maximum range of 3 display. Our value can be 3, then it's fine. So it will be 0, 0, 3. But if the value is 100, 35, can we make that output and compact it within 1 display? So every 7 segment display will show an output of a 1 decimal value. Do you get my point? 1 decimal value. So this 1 decimal value will be the ultimate outcome of a single 7 segment display. So how many displays should be set up over there just to get the output of the LM35? How many display do you need?
3, because we 100 degrees Celsius.
Okay, so we need 3 7-segment display. Okay, fine. We need 3 7-segment display. So if we need 3 7-segment display, how can we connect this 7-segment display with the Arduino? So I didn't talk about the multiple connection. So I have told you about the single connection with the Arduino. But what will happen if we connect this 7-segment display, right? So that's the question. Before that, do you know this is the common cathode? As I have told you that that's the very user friendly to use. You can use the anode module as well. But whenever you want to choose any 7-segment display, that's the time this common cathode display is the most prominent and the significant one to use, because the common cathode means the cathode will be the common, and we can connect this ground and make it short. Okay, if I am not wrong. Okay, make a short. The fact is, if we make a short over there and connect with the one wire, do you think is it okay or it's not going to work? Like you have a value 35351. So if you connect these pins internally like this and make a short and connect one wire with the Arduino, do you think you can show different value over there?
No, sir.
Exactly, that's not possible, because if you show the output over there, it will be 3, it will be 3, it will be 3 as well. Okay, so you have to make sure that you want to put 3 in the display 1, you want to show 5 in display 2, you want to show 1 in display 3. Okay, so there will be CCO, CC1, CC2. So different common cathode represent different signals, different display. Like the scorecard of Tamim Iqbal is now 46. So if the scorecard will get short over there, it's the same scorecard that you are watching whenever you are on a stadium, on a TV show, on wherever it is. Okay, so what will show over there? They will be showing something like 6, 6, 4, 4, because you have shorted the ultimate result. So what it will get? then it will show you the same as the previous one or the first one or the single digit, same will represent to the each display. So what's the solution? What is the solution? Okay. Before that, do you know how to connect the LEDs of digital display? I have showed you the last lab, Sabir.
Yes, sir.
So there are lots of digital pins over there. 1, 2, 3, 4. So what you have to do is to connect with the resistance. So it's possible to connect with the resistance. You can make the connection without the resistance as well. I have showed you to the last class, because 7 display there will be 7 resistance. For this there will be 7 resistance. For this there will be 7 resistance. Then you can make the ultimate output. But how? What we are doing right now, we make an internal short. Do you get my point? We will make an internal short. Okay, let's think about that. So the display has 7 legs, if I'm not wrong, 7 or 8 legs. Sabir, how many legs of a simultaneous display? 7 legs. Okay, so if you set the 7 legs, and set the 7 legs in side by side, what will happen? You have to connect the wire internally and get a point, and with the value of the resistance you can manipulate each. Now you can say that this could be the A, okay, this could be the B, C, D, E, F, G, is it? And there is a H, okay. So if you connect this A, you can say, sir, my value is 357. So how can I conduct the 357 in the different display? That should be the question. That's not the concerning issue, because you have disconnect this CCO. So definitely you will get the individual value. Okay. So these pins are just to power up, and as they are cut, as they are not connected, they are cut off from each one, then they will definitely get the value individually from each one. Basically, it's a parallel connection. Whenever they need, they will just lighten up that particular LED.
All the pins are connected in one point.
Which one? This one or this one?
Oh, sir, the legs, 3 displays, A pin are connected in parallel.
Yes, these are connected in parallel. So the fact is, whenever they need, it will convert to a VDR, voltage divider rule. The Arduino will power up, provide a particular output as a significant amount of voltage and current, and it will drop over there, and then the rest of the value will power up this one, this one, this one. That's simple. And how they will conduct, on how they will shifting the voltage or the value or the lighten up the LED, that will be depending on your code. Okay. So the main game is over there, because you have disconnected it. So they will convert to a different display. So now you are just powering up in a parallel connection to reduce or lessen the wear. Think about that. If you just want to connect 7, 7, 7, 21 pins, do you think Arduino Uno has 21 digital pins?
21?
No, just 14, 13, 0 to 13, is it? That's why you have utilized just 7 digital pins of this circuit diagram of this Arduino. Okay, so that's the most important thing that I want to discuss with you.
Sir, CCO, CC1, CC3, this point of time, where?
Okay, let me finish. I'm not just in it and summarize this whole things. Okay, fine. So these are the pins of port C. Very good question. Here is the port C. Now, tell me, what is port C? Find out. What is port C? Analog pins Which ones? Just let me clear. Which ones? PC0, PC1, PC2. These pins considered to which actual pins or actual represented pin? Is it analog, PWM, or digital? You can no. You can say like this. You have to check, and you have to firmly say the answer. PCO, PC1, PC2. So there will be PC0, PC1, PC2. Tell me. You have the slide, you have the internet, you can Google and answer it to me. PCO, PC1, PC2. Yes? PB, PD. Analog pin. Is it PWM or just analog? A0, A1, A2, A3, A4, 5. Which one? Is it PWM pin or just analog pin?
Sorry, analog pin. Just analog pin.
Just analog pin. Are you sure?
Yes, sir.
Okay. So basically, these pins will connect with the different analog pin. Okay? Okay, fine. Now, what will be the analog pins? A0, A1, A2. Why? Tell me why I have connected this analog pin to the individual one. Because this 10-bit converter will process this value, and definitely it is a analog output sensor. Okay, so that's why you have to tell this cathode display that yes, the values will be considered to the analog sectors. Okay. Now the question is, so you have different segment pins like 7, 8, 9, 10, 11, 12, and there will be different point, okay, and each point considered to like this D. Okay, so these are the parallel connection actually. So after simplifying or making this connection, now can you just have a look over there and can any of guy understand what's happening there? It's quite impossible unless you get to know there is 3 sections. See, this is the one. Okay, this is another one, and this is the third one. That's very simple. What I am doing over there, it is just very simple as you can think. Input section, I am taking the value from the environment. Processing unit, I am just process the value and connect the simplest wire. And the output one, I have shorted the wire and what? Simplify the different cathode display to get our value. Now, after putting the code, you will get your results. Okay, that's a very important thing, and it might be maybe come to the final exam. Actually, it's very important, and the coding section is very important as well because you have to know the codes. Okay, so now draw this diagram to your lecture page or lecture sheet, and I will check that. I'm going to check that. Okay. Don't make a copy. If you understand this one, what you have to do, you have to just draw this one with your own knowledge, with the help of the board and with the help of the slide. So if the question comes like this, that what's the basic difference of common cathode versus common anode display? So what will the answer? The common cathode display uses the ground, okay, at any kind of pin number, and high to turn the respective LEDs. Make high to turn the respective LEDs. Okay, so there are 7 LEDs. So these are the respective LEDs, and it will turn high. I mean, they will get the value of 1. I mean, they will power up. They will lighten up. Okay, and while the common anode display uses the VCC pin, the plus pin, and a low to turn the respective LEDs on. So these are difference. What? We use the cathode pin as a ground pin. So at the same time, we uses this cathode pin. I mean this pin, ground pin, as a voltage pin. Okay. So this is the simplest thing. So you are connecting the cathode pin, and at that time it will turn up the LEDs. And you are using the anode pin as a VCC, and then it will turn up the LEDs. So yeah, you have to find the answer by yourself. Where is the power and how can you get the power? So this significant cathode pin is the ultimate power pin. Okay, what you are do right now, what you are make it calculated over there. This CCO1 is a cathode and will consider as a ground, and the anode it will consider as a voltage. That's the simplest thing. In the anode section, it will consider as a voltage, okay, and in the cathode section, it will consider as a ground. There is no power port. This is the single power port, because you are connecting all the LEDs with different values. Okay, you are connecting all the LEDs with different values, with different pins. But for this specific leg, is a cathode leg or anode leg. That's the simple thing. Okay, so whenever you are using the cathode, you are considering it as a ground, to make sure all the 7-segment display respective LEDs, and at the anode pin, you are considering it as a VCC. Okay, you have to power up with a VCC. That's the same thing. That's the simplest thing. Where are the resistance? What is the reference pin? 1.1 V reference. Okay, in the next class, we'll learn about the conversion, how the temperature forms and how this temperature comes to a value. That's the algorithm and the thoughts, and after that you have to write the codes. Okay, and the second part is after getting the value, how we are going to interact this value and show the output in the display. So there will be two code and make it and we have to merge it. Okay, for a huge line of codes. Basically, it's not a huge or commands. It's very simple if you understand it in the simplest way. Okay.
Find the code for children 9 digital.
There's lots of codes in the internet. You will find lots of codes over there. But yes. Yeah. Yes. So that's the main fun fact, that it won't run actually. So to accomplish this code, to launch this code properly, you have to understand the concept, and we have to write down the course, and we have to get to know the course very, very easily. Okay, fine. So that's all for today. You may turn off the video. Thank